Today we will discuss about Jacobian of implicit function. Jacobian of implicit function. So here we see that some functions are given in this form. First we start with the example. Suppose x square plus y square is equal to u plus v. X plus y is equal to u square plus v square. So in such type of functions, we cannot say that u v work as a dependent variable or xy work as a dependent variable. So that type of function is called the implicit function. Okay, we cannot say that xy is the function of uv or uv is the function of xy. So we start the first part of the implicit function, that means taken two variables. So if the variables u and v are connected implicitly with the independent variable x and y by the relation we write down as f1 is function also we make the functions. In such cases, we make the function. Number of relations, that means two relations are given. We make two functions. So f1 and f2 of all variables x, y, u, v is equal to 0. We make a number of functions as per the given relations. So two relations are there. So that we make two functions of all variable x, y, u, and v. So then Jacobian of f1, f2 with respect to, so here we write down the independent variable x and y. So with respect to x and y, so this can be written as minus 1 raised to the power 2. So this negative sign we taken as uh, on the basis of the functions. So how many functions we made? So that means we make two functions, so minus 1 raised to the power 2. So del f1 into f2 upon del ub into del ub upon del x y. Okay, so this is for two variables. This is for two variable. That means u and v, which are connected implicitly with the independent variable x and y. Okay, so here mentioned that that means x and y work as independent variables. So that's why we write down this thing. Okay, so this is our first theorem. We can prove also this one when we got this minus 1 raised to the power 2 sign. Now, when we want to calculate del uv for implicit function, del uv upon del xy. So this can be written as minus 1 raised to the power 2 del f1 f2 into xy upon del f1 f2 upon uv. Okay, so we need this formula to solve the problems. Now, similarly, we write down for three variable u, v, and w are connected with x, y, and z. So second, we write down as we will do later. So we write down as if the variables u, v, and w, we connected implicitly with independent variable x, y, and z by the relation so here we have three variables u, v, and w, and three independent variable x, y, and z. So we make three functions. So we make three functions. So we can write down the function as x, y, z, v, w is equal to 0. Second function again x, y, z, u, v, w equal to 0. And third function x, y, z, u, v, w equal to 0. So make three functions. So on the basis of that, we calculate then Jacobian of f1, f2, f3 upon independent variable we have considered as x, y, z, so equal to minus 1 raised to the power 3. So make three functions. Minus 1 raised to the power 3 into del f1, f2, f3 upon del u, v, w into del u, v, w upon del x, y, z. Okay. So similarly, we need to calculate del u, v, w upon del x, y, z. So we write down this as minus 1 raised to the power 3 del f1, f2, f3 upon del x, y, z upon f1, f2, f3 upon del u, v, w. So we remember these formulas for calculating the Jacobian of implicit functions. Similarly, we can write down for the general term. So for write down the general term, that means if we take in the form of u1, u2, u2, u1, u2, u3, un are connected implicitly with independent variables x1, x2, x3, xn. So then uh, by the relation, we first by the relation f1, x1, x2, x1, xn, u1, u2, un is equal to 0, f2, x1, x2, xn, u1, u2, un is equal to 0, and we write down the nth, that means fn, x1, x2, xn, u1, u2, un is equal to 0. So we have n functions here. So when we make n functions, so then we calculate Jacobian of f1, f2, Fn with respect to x1, x2, xn is equal to, we have an n function, so we write down minus 1 raised to the power n into f1, f2, f3, fn upon u1, u2, un into u1, u2, un upon x1, x2, xn. Okay, so we remember this one. This is the general case, or we can calculate u1, u2, un with respect to x1, x2, xn. So we write down this as minus 1 raised to the power n del f1, f2, fn upon del x1, x2, xn upon del f1, f2, fn upon del u1, u2, un. Okay, so this is for general case when we have n variables with respect to n independent variables. Okay, so we take problems related to that, so you can understand easily how to use this. So first problem, we start with if uq plus vq is equal to x plus y, and u square plus v square is equal to x cube plus y cube. Then show that del uv upon del xy is equal to y square minus x square upon 2uv u minus v. Okay, so here we make two functions because two relations are given. So when we do the solution, so let the function f1 of all four variables, that means x, y, u, v, is equal to first function we make for first relation, uq plus vq minus x minus y is equal to 0. So this is our first relation, the first function from first relation, and second function also x, y, u, v. So this equal to u square plus v square minus x cube minus y cube is equal to 0. So when we are going to solve this del ub upon del xy, so from this we can see that that means xy work as a independent variable. Okay, so we calculate del uv upon del xy. So when we calculate del uv upon del xy, so we use the first result, this result. So when we are going to calculate this del uv upon del xy, so we write down this as minus 1 raised to the power 2 f1 f2 upon xy upon f1 f2 upon uv. So we write directly. So we can write down as del, that means Jacobian of uv upon xy. So we have two functions f1, f2. So we write down minus 1 raised to the power 2 into del. So we f1, f2 upon. So first we take with respect to xy upon f1, f2 upon uv. Okay, so minus 1 raised to the power 2 means positive. So we solve the first numerator. So this can be written as del f1 upon del x, del f1 upon del y, del f2 upon del x, del f2 upon del y upon denominator. So denominator del f1 upon del u, del f1 upon del v, del f2 upon del u, del f2 upon del v. Okay, so we solve this one. So we have a del f1 upon del x. So this is function f1. When we differentiate this with respect to x, so we treated u, v, y as a constant. So this is minus 1. Del f1 upon del y also minus 1. Del f2 upon del x. So del f2 upon del x is minus 3x square. Del f2 upon del y minus 3y square upon denominator. So del f1 upon del u. F1 upon u means 3u square. 3u square. Del f1 upon del v, 3v square. Del f2 upon del u, 2u and 2v. So we solve the determinants. So when we first we solve the numerator determinants, so leading the multiplication of leading diagonal. So this gives us 3y square and minus or both term having of diagonal having negative sign, so minus minus plus. So this gives us x square upon denominator, that means 6 u square v minus 6 u v square. So we take 3 as common from numerator. So this gives us 3y square minus x square, and 6 we take common from denominator. So this gives us u minus v. So 3 2 is 6. So this equal to y square minus x square upon 2uv and u minus v. So this is our result. Okay. So this is the first question. Now we solve another question. The second question we take as if x plus y plus z is equal to u, y plus z is equal to uv, and z is equal to uvw. Show that del x y z upon del uvw is equal to u square v. Okay, so these three relations are given. Previous question we have solved for uv upon xy, but here we solve for xyz upon uvw. Okay, so in this relation, that means we see that uvw work as independent. So we first we see that how many relations are given. So three relations are given. So on the basis of three relations, we make three functions. So the given relations can be written as, first we assume that f1 function. So for first function, we can write down as for u, v, w, x, y, z is equal to x plus y plus z minus u equal to 0. So this is our first function. Okay. So for second, u, v, w, x, y, z. So f2 is function of all six variables. So this can be written as y plus z minus uv is equal to 0. And third, f3. So u, v, w, x, y, z. So this is no need to write in F1, F2, F3, because this is understood that means function F1 is a function of all six variables. So this can be written as z minus uvw is equal to 0. So this is our equation number 3. So we have three functions, three equations. So we have to calculate Jacobian of x, y, z upon u, v, w. So this equal to same rule, that means minus 1 raised to the power 3, but we change into the formula. So here we write down as first Jacobian of F1, F2, F3 with respect to x, y, z. With respect to UVW first upon F1, F2, F3 with respect to x, y, z. Okay, so we write down this as minus 1 raised to the power 3 means gives us negative sign. So F1 upon U, F1 upon V, F1 upon W, F2 upon U, F2 upon V, F2 upon W, F3 upon U, F3 upon V, F3 upon W, upon F1 upon X, F1 upon Y, F1 upon Z, del F2 upon del X, del F2 upon del Y, del F2 upon del Z, del F3 upon del X, del F3 upon del Y, del F3 upon del Z. Okay, so we simplify this. That means both the numerator and denominator you can solve separately also. So we solve separately. That means first we solve the numerator, then denominator. So this is our numerator part, numerator, and this is the denominator. So first solve numerator. So first we solve the numerator. So we write down this as del F1 upon del U. Del F1 upon del U. This gives us minus 1. Del F1 upon del V. So function doesn't have V or W terms. So that means derivative will be 0. So we write down as 0, 0. Del F2 upon del U. F2 upon del U. So this gives us minus V. Del F2 upon del U minus V. Del F2 upon del V gives us minus U. It doesn't have any term of W, so derivative will be 0. Del F3 upon del U. So this gives us minus VW. Minus VW. Del F3 upon del V. So minus UW. Del F3 upon del W. Minus UV. So we see that the upper triangular is 0 of the determinants. So that means what is the determinant value? Determinant multiplication of the leading diagonal element. Multiplication of the leading diagonal element. So directly we write down the value. So multiplication of leading diagonal element minus 1 minus u and minus uv gives us minus u square v. Okay. So this is the numerator solution. Now we solve the denominator parts. Solve denominator. When we solve the denominator, so we write down as del f1 upon del x. F1 upon del x. So this means gives us 1. So del f1 upon del x 1, del f upon del y 1, del f upon del z 1, del f2 upon del x. Function 2 having a term only y and z. So del f2 upon del x means 0. Del f2 upon del y 1, del f2 upon del z 1. Third function having only term of z. So we write down as 0, 0, 1. Here we see that the lower triangular is 0. So the determinant value of this equal to multiplication of the leading diagonal element. So multiplication of leading diagonal 1 into 1 into 1. So this gives us 1. So the value is 1. So this equal to 1. So when we put the value into the above equation, so we see that the value now the value of Jacobian of x, y, z upon UVW is equal to minus. So we have the negative sign and the numerator we have calculated as minus u square v upon denominator we have calculated as 1. So this minus minus is plus, so we have u square into v. So we have this result. Okay. So our result is obtained. So proved. Now we move to the So further question related to that. So one more question we will discuss. If U UQ plus VQ plus WQ is equal to X plus Y plus Z, U square plus V square plus W square is equal to XQ plus YQ plus ZQ. And the third equation, U plus V plus W is equal to X square plus Y square plus Z square. Show that del UVW upon XYZ is equal to Y minus Z, Z minus X minus Y upon U minus V minus W minus U. So we solve this also. In previous question, we see that we have calculated del XYZ upon del UV, but here we calculated del UVW upon LXY. So we have to remember this. Okay, so these problems are related to the implicit function. So we can check by using the LHS part of the required question. That means UVW is function of XYZ or XYZ is function of UVZ. On the basis of the relations, we cannot say that, but when we have the LHS part, so we can see that. So that means here we see that UVW work as a dependent and XYZ work as a independent variable. That means they are connected implicitly with independent variable X, Y, and Z. Okay, so we make functions. So three relations are given. So make three functions. So we write down as so the variables UV and W. UV, W are connected implicitly with X, Y, and Z by the relation. So we make three functions. So first function we make as this is equivalent to, so that means we write down a UQ plus VQ plus WQ minus X minus Y minus Z equal to 0. So this is our first equation. Second function we make from second relation U square plus V square plus W square minus XQ minus YQ minus ZQ equal to 0. Third F3 we make as U plus V plus W minus X square minus Y square minus Z square equal to 0. So we make three functions on the basis of given relations. So now we obtain Jacobian of UVW with respect to X, Y, Z. So this equal to the three functions we write down directly minus 1 raised to the power 3 into F1, F2, F3 upon XYZ. So first we solve for XYZ upon F1, F2, F3 upon UVW. Okay, so we solve in similar manner. So first we So minus 1 raised to the power 3, this gives us a negative sign. So we take the negative sign. We write down as del f1 upon del x, del f1 upon del y, del f1 upon del z, del f2 upon del x, del f2 upon del y, and del f2 upon del z, del f3 upon del x, del f3 upon del y, del f3 upon del z. Here we write down del f1 upon del u, del f1 upon del v, del f1 upon del w, del f2 upon del u, del f2 upon del v, del f2 upon del w, del f3 upon del u, del f3 upon del v, or del f3 upon del w. Okay. So similarly, we solve separately numerator and denominator. So this is our numerator part. This is denominator. So first we solve the numerator. So on solving numerator. When we solve the numerator part, so we see that del f1 upon del x. Del f1 upon del x. So this gives us minus 1. So del f1 upon del x minus 1. Del f1 upon del y also minus 1. Del f1 upon del z also minus 1. Second, del f2 upon del x, f2 with respect to x. So this gives us minus 3x square. Del f2 upon del y, minus 3y square, derivative of y cube. Del f2 upon del z, minus 3z square. And third row, del f3 upon del x. So del f3 upon del x gives us minus 2x, minus 2y, and minus 2z. Okay. So when we simplify this determinant, so we see that row 1 having negative sign, row 2 also having negative sign, row 3 also having the negative sign. So we have three negative signs, so minus 1 raised to the power 3 minus, and we can take common from row 2 3. So 3 we can take common from row 2. So we take 3 from row 2, and we can take common 2 from row 3. So we see that this can be written 1 1 1, or x square, y square, z square, and x, y, z. So this we can write down as minus 6, and we can interchange R2 to R3. So we can interchange here also R2 to R3. So we write down as this 1 1 1, x, y, z, x square, y square, z square. Okay. So we have a direct property of determinant for such type of cases. You can use that property also, or you can simplify determinant. Okay. So the property, we write down the property. So we have the property. So remember this property. Okay, if the determinant in this form 1 1 1, a b c, a square, b square, and c square. So the value of the determinant is a minus b, b minus c, c minus c. Okay, so you can write down for this also. So we can write down this as minus 6 into, so x minus y, y minus z, and z minus x, by using this property directly. Okay, so this is our numerator, and on solving denominator. On solving denominator. So when we solve the denominator part, so denominator, we have f1 upon u. So del f1 upon del u. So del f1 upon del u means 3u square. Del f1 upon del v, 3v square. Del f1 upon del w, 3w square. So we write down as del f1 upon del u, 3u square, 3v square, 3w square. Del f2 upon del u. Del f2 upon del u, 2u, 2v, 2w. So this will be 2u, 2v, 2w. and third one is 1, 1, 1, because we have u plus v plus w. So 1, 1, 1. So similarly, when we simplify this determinant, so we can take a 3 as common from row 1 and 2 from row 2. So 3 into 2, and we write down as u square v square w square u v w 1, 1, 1. Okay. So while interchanging the row of this determinant, so we can interchange the rows of the determinants. We can write down this as u square v square and w square on interchanging the rows. So similar property we also use. So we write down using the property. So the value of this is also u minus v, v minus w, and w minus u. So on putting the value of numerator and denominator in the using the value of numerator and denominator. So we see that, so del u v w upon del x y z is equal to minus 1 raised to the power 3 means minus. So minus, and the numerator having minus 6. So numerator value is minus 6 x minus y, y minus z, z minus x. And the denominator having 6 u minus v, v minus w, w minus u. So minus sign to minus sign cancelled. So this is 6 x minus y, y minus z, z minus x upon 6 u minus v, v minus w, w minus u. So this 6 to 6 cancelled. So our result is Jacobian of UVW upon x, y, z is equal to x minus y minus z, z minus x upon u minus v, v minus w, w minus u. So we have proved the required result. Okay, thank you.